Today we're going to be talking about ratios, and we're going to understand what a ratio is, but also we're going to use ratio vocabulary to describe relationships between two quantities, and we're going to understand what a unit ratio is compared to just a regular ratio. So you should have your foldable pasted into your notebook already for me. As we begin our notes, you will have your definitions of a ratio and an equivalent ratio kind of at the top of your paper with the pictures. So, just to review, the first definition says a ratio is a comparison of two amounts that can be expressed three ways. And those three ways include using a colon, using the word to, and also using a fraction. Now, it's important that when you read ratios, the order in which you read them is the order in which you write them, even when they're in fraction form. The first number is always the numerator, the second number is always the denominator. Equivalent ratios are ratios that have the same value. So the example given says there are 1 to 2 white to dark circles compared to 2 to 4 white to dark circles. If you wrote these as fractions, 1 to 2 and 2 to 4, you can easily see that they equal each other because 2/4 simplifies back down to 1/2. So that ratio is constant. They are equivalent ratios. We're going to fill in our table notes. First, a ratio is a relationship of two or more numbers. And the relationship is comparing those two numbers. So an example is the ratio of stars to circles is 2 to 3, right? I have 2 stars compared to 1, 2, 3 circles. Again, you can write this ratio in 3 different ways. I can say 2 to 3 with a colon, or 2 over 3 with a fraction, or just 2 and the word 2, 3, like it was written in the sentence. Again, there are 3 ways to write a ratio: with the word 2, with a colon, and as a fraction. It's really important to know that there are multiple ways to write a ratio, especially when you're looking at fractions. You want to really be strong with understanding how fractions work so that we can do lots of equations with ratios. A rate is a ratio, but it compares two numbers with different units. What do I mean by units? I mean something like this example. A car travels 100 miles in 2 hours, right? So miles is the first unit and hours is the second unit. I'm not comparing miles to miles or hours to hours or seconds to seconds. I'm comparing miles to hours. There are 2 different units here, so it is a rate. What you should know is that a unit rate tells the rate in lowest terms, or the amount for 1. So when I have a unit rate, I want my denominator to be equal to 1. So for example, if I had 100 miles for every 2 hours, I would want to make that 2 so that it turned into a 1. I can do that by simplifying my fraction. So 2 hours turns to 1 hour, and 100 miles turns to 50 miles. Now I have a saying in terms of 50 miles per hour. That's a much simpler way to describe the rate rather than saying I go 100 miles every 2 hours. A proportion is an equation, and it shows that 2 ratios are equal. So the example says 10 over 25 is equal to 40 over 100. I would be able to know this for sure just by simplifying both ratios or one of the ratios, right? If I decided to simplify 40 100ths so that I had a denominator of 25, I could divide both my numerator and my denominator by 4, and it would equal 10 25ths, which is the same as my first ratio. in a proportion, if the ratios are equivalent, then the cross products are equal. And it says think of equal fractions. I just want to show you quickly, in terms of the example above, 10 over 25 is equal to 40 over 100. The cross product really means what happens when I cross multiply. So 10 times 100 is equal to 1,000, and 25 times 40 is also equal to 1,000. So the cross product, meaning if I multiply the numerator of my first ratio by the denominator of my second, and the denominator of my first ratio by the numerator of my second, I'm going to get the same numbers on either side of my equal sign. That's important for solving ratios when we don't know all of the parts, if we're missing something. So lastly, your proof today says there are 5 boys in math class and 8 girls. Write the ratio of girls to boys in 3 different forms. Hopefully you remember what those forms are.